Okay, well, this video will show how we create confidence intervals based on a population. So we're going to work this problem here. We're using this data that was provided. We'll calculate to come up with the confidence interval and to determine whether the population falls within the interval. We're going to do these 5 things. We're going to calculate the mean of all the park acreages. That's the population mean. We'll select a random sample of 20 of them. We'll calculate a sample mean, and we'll construct a 90% confidence interval around that mean. Okay, now we're going to assume that this is the data given here. It's acreages, and there's 50 of them. Okay, if I slide down, I'll eventually show you that we get to the total. Okay, so that we're going to assume this is the data we have. And if we calculate the total of this, I'm just using Excel's sum function, right? Equals sum, left parenthesis, B2 to B51. That gives me the total. Okay, now you can either look down here where my mouse is pointing, or you can look up here on the, I call this the formula bar. Okay? Now, we know there's 50, so we could divide by 50, but I'm going to take advantage of Excel's count function where I say, give me the count of rows B2 to B51, and there's 50. And then, of course, if we were to divide the total by the count, we could come up with the average. But Excel also has an average function. So here I could just type in equal average, left paren. Now I tend to come up here and click this button so that I can see where I'm going. And then I go to the first item. And I just keep sliding down. I'm going to slide a little bit too far so that it scrolls and you can see it. Okay, and when I hit enter, that gives me the average, and I don't have to worry about that. It knows that's an array. Okay, and I come up with 910. It's actually 910 point something, but we're only going to display whole numbers. All right, now in order to construct the confidence interval, we also need to follow through on the problem, and the problem said select a random sample of 20. Okay, so I just randomly copied over the 20. I actually used an Excel function and just, cut and paste in various places, and I've got 20 of these done. How do I know? I'm using that count function again, and there's 20. The total of those was 21,102. Okay, so my total, the population is 45,521. My sample is 21,102. There's my count, my population or sample, right? Sometimes the variable n is being used, right, to represent that. Sometimes big N, little n, right? All right. So then we have a mean, which is the average of the population. Here's the average of the sample. Now, in order to come up with a confidence interval, we have to come up with a critical t-value. And you can get this from a table or from Excel. Okay, so here's a table where we can get the t-distribution. So in this case, if we're looking for a 95% confidence level, remember that 5% has to be spread to the lower tail and the upper tail. So we would use 0.025. We're going to find the tails independently. So half of the 5%, right? And then you would just figure out what the degrees of freedom are. And the degrees of freedom would always be your population minus 1. So let's say we only had 20. Oh, no, I'm going to use a different number. Let's say we only had 15 in our population. Then we would use 15 minus 1 is 14, and we would move over to 0.025, right? That would be half of the tail of a 95% confidence interval if we were using 95% as our confidence, and we would use 2.145. Now, if we only wanted 90% confidence, well, then we've got 10% between the two tails. So in one tail, we would have half of it. We would use 1.761. And again, this assumes we had a population of 15, and degrees of freedom is always population minus 1. Okay, that's one way you could find that confidence interval. But Excel helps you out, and I'll show you that I actually worked this ahead of time for you. Let me call this up. All right, now I moved the table out of there so it's not in our way. So when I click on this cell, or bring up this formula, we can see what the formula is, and the formula is equal t.inv.2t. Okay, that's the name of the formula. Then you put a left paren and you could call it up. And in our case, the probability of it falling outside of the normal distribution is 10%. And we're using a two-tailed inverse of the student's t distribution. Okay? For our purposes, all we really need to know is to solve a confidence interval based on a population. If you're looking for the critical value, the formula is t.inv.2t. And then we would give it the probability. This is the probability of it not being in the normal distribution. And since our question, our problem is asking for a 90% probability, we put 0.1, 1 minus what would fall under the normal distribution. And the degrees of freedom are given in cell B53. Here, I'll type that in again. We would just point to it. B53 is the count, or the population, right, minus 1. Okay, and that's 49. So when I hit enter, I can come up with my critical t value. And of course, we could have got that from a table as well. All right, now that I've got my critical t value, we've got some math to do. And this is the formula that we have to use for a confidence interval upper bound when we know the population. So we take the sample mean plus or minus the critical t value, that's the number we got right here, times standard deviation of the sample divided by the square root of the number of the population. So I've done the work here, and you can see what I'm doing here. I'm taking the value of D54, which is 1055, that's our sample mean. Okay, then I'm adding to it B56, that's my t value, and I'm multiplying it, and I'm just working on the last term now, times S, and S is given by the standard deviation of our sample, 1770, divided by the square root of B53. Okay? And you can see I'm using a function within a function. Okay, you could do it that way. Now, if you really didn't want to use the function, you could also just use the caret. I don't know if you remember this, but to find the square root of a number, you can take it to the power of 1/2. So you could have put in here B53, right, which is the 50. Excel uses the caret as the power. It's raised to the power of 0.15. Okay, and when I do that, I'm going to get the exact same number. Now, I think it's easier to read this with the square root, so I just did the undo command to put it back there for you. All right, and then we have to do the same thing for the lower bound, only instead of adding the t value, the critical t value times the standard deviation of the sample divided by the square root of the population number, right, the count of the population. Instead, we're going to subtract it. So it's the exact same formula, only with a minus before that second term. Okay, and when we do that, we come up with the confidence interval of the lower bound. Now, keep in mind, I'm using Excel to do the math, but you could do this with a calculator, right? There's the formula. You could do this by hand, or you could put the numbers in one at a time. You know, you could put square root somewhere else and then use Excel to multiply it, and either way is fine. Actually, any way you get to it is fine. All right, so then what we do is we just say, well, what was the confidence of, now I need to move it up so you can see the screen. What was the confidence lower band? Well, that was 635. The sample mean we came up with is 1055, and the confidence interval was 1475. So what we've concluded is that the sample mean did indeed fall within our confidence interval range. Okay, so to review, did we calculate the mean of the park acreages? Did we calculate the population mean? Yep, we did. We came up with population mean was 910. Did we select a random sample of 20? Yes, we did. We came up with 20. There's the count of 20. Did we calculate the sample mean? We sure did. We used Excel's average function to do it. Of course, you could have, simply taken the total and divided by the count. You'll get the same number. Again, this one I've got formatted to no decimal places, but it's actually using whatever the real number is with all of its decimal points. We're just not seeing it. Okay, did we construct a 90% confidence interval? Yes, that was probably the hardest part because we had to come up with a critical t-value and then use this formula to determine the confidence interval at the upper and the lower amount. And then the last one, did we determine whether the population mean can be found within your confidence interval? And we said yes. Oh, let me clarify. We want to use the population mean here, not the sample mean. So the population mean was 910. And 910 also falls within the confidence interval. Okay, just to clarify. All right, I hope you found that beneficial.